just let what I believe history will record that America's challenge of today has forged man's destiny of tomorrow. And as we leave the moon in Taurus literal, we leave as we came, and God willing, as we shall return, with peace and hope for all mankind. Godspeed the crew of Apollo 17. 3, 2, 1, ignition.
That year, 48 years ago, the last human being walked on the surface of the moon. However, in 2024, humanity is finally set to return. This mission will be called Artemis. This will be a triumphal return to the moon for the United States and the entire human race as we embark on a new era of human space exploration and long-term colonization with permanent bases on both the moon and Mars, and laying the foundation for sustained manned missions even further into deep space.
Thank you very much.
On December 11th, 2017, exactly 45 years to the day after the crew of Apollo 17 touched down on the lunar surface for the last time, President Trump signed Space Policy Directive Number 1. Joining him was Apollo 17 astronaut Harrison Schmitt.
Finally, we're honored to be joined by Apollo astronaut Jack Schmitt. Exactly 45 years ago, almost to the minute, Jack became one of the last Americans to land on the moon. Today we pledge that he will not be the last, and I suspect we'll be finding other places to land in addition to the moon. What do you think, Jack?
Space Policy Directive Number 1 declared that America was going back to the moon and onwards to Mars and beyond.
The directive I'm signing today will refocus America's space program on human exploration and discovery. It marks an important step in returning American astronauts to the moon for the first time since 1972 for long-term exploration and use. This time, we will not only plant our flag and leave our footprint, we will establish a foundation for an eventual mission to Mars and perhaps someday to many worlds beyond. Today, the same spirit beckons us to begin new journeys of exploration and discovery, to lift our eyes all the way up to the heavens and once again imagine the possibilities waiting in those big, beautiful stars if we dare to dream big. And that's what our country is doing again. We're dreaming big. This is very exciting and very important for our country. And it also happens to mean jobs. Jobs. And we love jobs too, right?
A year later, with Space Policy Directive 2, the White House announced that NASA was partnering with SpaceX to return America to the business of carrying astronauts into low Earth orbit. On May 30th of this year, the world watched as the SpaceX rocket Falcon 9 successfully launched with the Crew Dragon capsule on top, containing astronauts Doug Hurley and Robert Behnken on their way to the International Space Station. The Falcon 9 lifted off from Launch Pad 39A, the same launch pad which launched the Saturn IX, carrying Neil Armstrong, Michael Collins, and Buzz Aldrin on their first trip to the moon.
Flying crew on board Dragon and Falcon 9, and look at them go!
Today, as we gather in this special place to celebrate not only the launch of a new spacecraft, but also our nation's bold and triumphant return to the stars, it's a special day. Moments ago, the world bore witness to the flight of the first new manned U.S. spacecraft in nearly 40 years. I am thrilled to announce that the SpaceX Dragon capsule has successfully reached low Earth orbit and that our astronauts are safe and sound. The names of Hurley and Benkin will stand in the history books alongside those of legends like Alan Shepard, Gus Grissom, John Young. Now these brave and selfless astronauts will continue their mission to advance the cause of human knowledge as they proceed to the International Space Station before returning to Earth. We wish them Godspeed on their journey, and as one proud nation, we salute their fearless service. When I first came into office 3.5 years ago, NASA had lost its way, and the excitement, energy, and ambition, as almost everybody in this room knows, was gone. There was grass growing through the cracks of your concrete runways. Not a pretty sight, not a pretty sight at all. The last administration presided over the closing of the space shuttle. People were crying, they were devastated, but now, for every citizen who has eagerly waited for America to reignite those engines of will, confidence, and imagination that put a man on the moon, I stand before you to say, you need wait no longer. Through NASA's Artemis program, the United States is preparing for a crewed mission to Mars. Earlier this week, I saw the Orion capsules being worked on in this building. As part of the Artemis Moon to Mars program, those capsules will soon return Americans to lunar orbit for the first time in over 50 years, half a century. By 2024, our astronauts will return to the lunar surface to establish a permanent presence and the launching pad to Mars. And the first woman on the moon will be an American woman, and the first nation to land on Mars will be the United States of America. So today, as our brave American astronauts shake the Earth and blaze a trail of fire and steel into the heavens, we proclaim for all to hear that we have not yet tested the full strength of the American character, and the world has not yet seen the full glory of the American spirit. For our country, for our children, and for humanity's march into the stars, the best is yet to come.
On August 2nd of this year, that mission came to its successful completion with the perfect splashdown in the Gulf of Mexico, the first splashdown of a manned space capsule to occur in 45 years.
Today we're flying into low Earth orbit, and in a few short years we want to be flying to the moon. And not just go once or twice, but we want to go sustainably with a purpose. We're going to learn how to live and work on another world for long periods of time. We're going to use the resources of the moon in order to live and work, and we're going to take all of that knowledge onto Mars. So today was an amazing day. It was a historic day. It's been 9 years since America launched and landed from its own soil, and yet here we are. But the next step is we're going on to the moon and then on to Mars. This is about momentum. It starts today, and it finishes when we put an American flag on Mars.
Yeah. What this heralds really is fundamentally a new era in spaceflight, a new era in space exploration. We're going to go to the moon. We're going to have a base on the moon. We're going to send people to Mars, and make life multiplanetary. And I think this day heralds a new age of space exploration. That's what it's all about.
Yeah, I'm not very religious, but I prayed for this one.
The intent of the leadership of NASA, headed by Jim Bridenstine, is to use this successful mission to reignite the excitement of Americans in the manned space program, as we mobilize over the coming 4 years to return man to the moon and land the first woman there too. These astronauts will be there to stay, with an orbiting lunar station called Gateway and manned research bases on the lunar surface, all preparing to continue the mission to Mars and beyond.
Yeah, I actually don't care at all about money, at all. But I do care about us becoming a space-faring civilization. What I really want to see is, permanent base on the moon, permanently occupy human base on the moon, and us building a city on Mars. That's like, if I can see the beginning of that before I die, I'll die happy.
Well,
But this triumph has been a long time coming. Over half a century. The same amount of time that elapsed between the Wright brothers' flights and the launch of the first satellite with Sputnik. And this too long delayed victory hasn't come without a hard-won fight, as even the leadership of NASA will tell you. Without understanding and fighting this battle, the victorious return of the manned lunar program is by no means guaranteed, and the dreams of the new generation of inspired young astronauts who now dream to fly into space and colonize other planetary bodies might be again tragically deferred. Ever wonder why Americans stopped flying into space from U.S. soil?
I understand that some believe that we should attempt a return to the surface of the moon first. But I just have to say, pretty bluntly here, we've been there before.
It was President Obama who canceled the shuttle program with no plan to replace it. He also shut down the Constellation program, which was launched in 2005 by the George W. Bush administration to replace the shuttle and allow for crewed voyages beyond Earth orbit to the moon and to Mars. And he replaced it with a widely derided asteroid capture boondoggle, which never got off the ground, and redirected NASA's manned space exploration budget to studying so-called Earth sciences and climate change. While Democratic candidate Joe Biden tried to claim after the launch of the SpaceX Crew Dragon capsule that it represented, quote, the culmination of work begun years ago and which President Obama and I fought hard to ensure would become a reality, the truth is that the Obama-Biden administration represented a destruction of the manned space program. As president, Biden's policy would most likely be a return to the space policy of the Obama administration. As the author of this op-ed in the Hill newspaper, Mark Whittington, asks, what would a President Biden do with NASA, commercial space, and the Space Force? The easy way to answer this question is that Biden's space policy would be Obama Space 2.0. The Artemis return to the moon program would be canceled, or at least delayed for so long as to be rendered meaningless. The author also warns that a President Biden could likely appoint former Obama-era NASA Deputy Administrator Lori Garver to replace Jim Bridenstine as NASA Administrator, who could, quote, turn the space agency into a climate change agency, an issue that Team Biden cares about far more than it does space exploration. Garver currently serves as executive director of a climate change organization called the Earthrise Alliance, and recently penned this op-ed in the Washington Post titled, Forget New Crewed Missions in Space. NASA should focus on saving Earth. In conclusion, Whittington correctly states, the voters deserve to know that they have a choice of two very different futures. The future proposed by President Trump would incorporate the moon and Earth-approaching asteroids into human civilization's economic sphere of influence. Not only will the frontier of science be expanded, but access to extraterrestrial resources would spark a space-based industrial revolution, which could enrich the home planet in ways beyond evaluation. Astronauts would make those first footprints on Mars. The future that Biden is likely to enable is a turning inward, a retreat from the high frontier. A world without limits versus one that is very limited indeed. That choice, little remarked upon, but very important nevertheless, faces American voters in election 2020, where space policy is concerned. The Artemis missions will clearly deliver some of the most seminal, revolutionary scientific achievements of this decade, and will shape the identity of an entire generation, just as Apollo shaped the identity of their parents' and grandparents' generations. The breakthroughs in science which will occur as we move mankind off this planet and make the first steps towards becoming a polyglobal species will serve as a rightful source of pride, excitement, and inspiration, not only for Americans, but for the world as a whole. But these potential future achievements are by no means guaranteed. They require that Americans place their identity in that future and fight today to make that future real.
We have before us the prospect of industrialization of the moon, which was devised actually in the 1970s and early 1980s by a friend of mine, a friend of ours at the time. And that's still valid. Now, if you want to go further into space, you want to go to higher levels of technology on Earth, you have to go into space. Because you have to have the challenge of going into space to get you to drive your technology upward and bring the benefits of driving it upward back to Earth and back to the benefits of mankind. We have to have a project of completing the moon assignment, which was what the push was then with Kennedy. It was not just going to the moon. The purpose was to industrialize the moon. And these would be largely automatic industries, which required automatic technologies. It would be industries controlled from Earth with very few people because, a low gravitational, electromagnetic gravitational field is not the best thing for your health. Right? And then the object is, what are we going to do with that? Well, we're going to go to Mars. And how would you go to Mars? Well, if you want to send something to Mars by inertial trajectory, you can do that. But I'd hate to send a human being out on an inertial trajectory for 200 to 300 days on a journey between the moon and Mars. It's not exactly, what's going to arrive there? Mr. Blob? So therefore, we have to think about accelerated flight. Well, we have on the moon a resource we recognize, helium-3. The sun has been depositing helium-3 as a mineral on the planet surface of the moon for a long time. There's big pits of ore of helium-3. Helium-3 happens to be a very useful item for space flight because it can be very directly applied to the propulsion process. We could technically, with helium-3 fusion, we could have a one-gravity flight from the orbit of the moon to the orbit of Mars, which will get you between the two planets within a few days. Now, there's some problems to be considered in venturing that, but if we can get to the planet from moon to Mars in several days by 1g gravitation or something comparable to that, that place is open to us, buddy. And whatever resources it has and whatever it means in the stepping stone to further things in space are now available to us. And once we adopt that policy, everything we've done in getting to Mars or getting to Mars now spills back on the planet as a revolution in everything we do on Earth. And the problems and challenges we face solve that. What this country needs, apart from reorganizing this economy in a sensible direction, we need to have, and there are a lot of people interested in this. We've got 10 nations now which are committed to a moon development project. 10 nations so far, committed actively. And I'm committed to a Mars arrival project. And we will change the nation of the nature of man's conception of himself. Man will no longer think of himself as an earthbound land grubber. Not land lubber, but land grubber. And man will think of himself as man in the solar system. Because man is, now this means a change of relationships of human beings to human beings. You got a human being on Mars who's working up there, a human being on Earth, it's a weekend travel to get up there and back, and so on. It's going to change the relationship in human life. All the technologies which are now used to do this will now be reflected in revolutions in technology back on Earth, including growing food stuff. I mean, growing vegetables on Mars. I mean, this is a real change in agriculture. It broadens your conception of what agriculture means. And that's how you do it. You have to adopt a national mission. And so we have to think about 2 or 3 generations ahead. I mean, don't you think about your grandchildren? Don't you think about even your great-grandchildren if you're lucky? Isn't that your mission in life? Isn't that your sense of continuity in life? So what's that? Generation 25 years. 3 generations, 75 years. 4 generations, 100 years. What are you going to be doing in the next 100 years, people? If you're thinking about the future, if you care about your children and grandchildren that are coming after you, if you think about future humanity and locate your identity in what you're doing for them to make their lives possible, what do you think about? You think about where we're going to be 75, 100 years from now. And think how accurately we can forecast where we might be. What are our options? Where are we going? What we should be doing? Hey, what are you going to do when you reach your retirement age at age 75 or something, or 70 or 85, with improved health care? What are you going to be doing with yourself? What's your future? What kind of a world are you choosing? What kind of a solar system are you choosing to live in? And that's the way you do it. You don't do it by coming up with a list of this, a list of that. What are your priorities? You go out with a mission for humanity. This is not about jobs. This is not about income. This is about humanity. The difference between man and a beast. What are you as a human being going to do that certifies you're a human being and not shameful in the result in the eyes of your grandchildren? What are you going to accomplish with your life? We accomplished something. We got so far. How far are you going to take us? How much further are you going to take the human race? And that's what makes it work. It's motivation. How you choose to spend your life. Not pass it, but spend it, expend it. To what purpose? To what end? What are you going to raise children for? To what end? For humanity. Why should you be remembered by people 2 generations from now? Why should you be respected a generation from now? What are you going to do to earn that respect? Your identity as a human being. And if you follow that line of thinking and use the space issue, space exploration as a parameter, a paradigm from our recent experience, which shows the difference, then you say, we don't talk about industrial policy as such, we don't talk about agricultural policy, we talk about human policy. We talk about the development and progress of the human species to a better life for future generations. And that takes scientific and technological progress, as well as the cultural progress which fosters creativity in the individual human mind. That's our mission. What we're getting is people got with these crazy categories of values, crazy, stupid, dull. They bore me. Now let's talk about going to the moon. That doesn't bore me. Because that involves exactly what we have to do step by step in terms of science and technology to do each thing we have to do to get each step along the way. And that's our mission orientation. We take that mission orientation and you find it works just fine.
Unfortunately, I'm hearing an echo, which is not too good, but I can do the best I can. By the way, Title is, Will the Real Sea Level Please Rise? Well, guess what? Take a look at that picture. Is the sea level? Not at all. So here are the sources of sea level rise. Not necessarily in order of importance. I could be talking about each of these. Model magic, thermal expansion, how we measure things, and worst computational errors. And then land-based ice melt additions, which I'm going to have to sacrifice because I wanted to show that movie. So let's take a look at suppositional model magic. So here's claims beyond belief, number one. Now, Arthur Gordon MacDonald testified to Congress since 1979. And then on the steps of the Capitol, predicted sea level by the year 2020. This was published all over the country in Discovery magazine. Guess what? It didn't even get to the laces of his shoes. This is 2020, by the way. So that's one wrong prediction. And let's look at what James Hansen did. He testified in 1988 that we were going to get 5 meters, 16 feet of sea level rise by the end of the century, by the end of 2100. He saw pretty quickly that that wasn't going to happen. So then he changed his tune. He said, oh yeah, we're still going to get to 5 meters. However, we're going to double it every 10 years exponentially. You notice by the time 2060 runs around, he's long gone. His prediction will, quote, not be disproved. And yet he still says we're going to be heading up 16 feet by the year 2100. Well, one of the world's greatest oceanographers, Niels Axel Mørner, studied what Hansen did. And like Hal Dwaren, our former chairman, he put a maximum possible limit. Hal did it for CO2, Mørner did it for sea level. And he said the maximum possible, if the rate of ice melting and thermal expansion all come together, it cannot be more than 10 millimeters a year. Now, if you notice, look really close at the bottom of this slide. You see that red dot? That's where I'm predicting sea level really will be. That is the 50% probability of sea level either being higher or lower than that red dot. Now I'm going to talk a little bit about oceanic thermal expansion. Now we all know that the upper layers of the ocean expand when heated by the sun. And I'm going to talk about this giant flying boxcar that the Europeans put up. It's called ENVISAT. About 18,000 pounds, largest satellite ever put in orbit. And by the way, they never reach above 480 miles. They're low Earth orbit. And that allows some accurate sea level measurement. Here's ENVISAT in the laboratory before it was launched. And this is how it actually calculates the sea level. And it uses the geoid, the ranging radars, and actually achieves sub-millimeter resolution. Let me show you what that looks like. You notice there is a 2 centimeter, not millimeter, difference in sea level rise on an annual basis around the world. Now you notice in the middle of each year, between 2005, 2006, 2007, 2008, in the middle of the year, sea level actually drops. In the winter months, it peaks. Now, why does that happen? Again, we have sub-millimeter resolution. This is damned accurate. This is the winter view of Earth. It's all ocean from the satellite. So the sun shines on the Earth. You notice the ocean is dark. The ocean absorbs that solar energy. And yes, thermal expansion heats up the upper layers of the ocean, and that's where you get that 2 centimeter difference. Now let's look at this way up. You know, Earth is one ocean, but we're measuring it in different ways. And I'm going to talk about how we are able to do that. This is GPS. It's actually what I call CGPS, which is co-located GPS. What you do is you take a GPS station and you match it and link it to a tide gauge. And this is the OD Newland. It's near Cornwall in England. And ODN Ordnance Datum Point Newland is the datum for the entire British Isles, co-located GPS. So the GPS measures subsidence at Cornwall at 0.7 millimeters a year. The sea level rise recorded there, according to the graphic, is 1.8 millimeters. The net rise in a validated, measured GPS located tide gauge is 1.1 millimeter a year. Now, by the way, in that graphic, you see a green line showing CO2 increasing. Well, guess what? The sea level at Newland in the UK has been linear for 100 years, and trust me, it's going to keep going that way. Now, GPS works on the west coast of the United States. You notice Alaska is experiencing uplift. You can look at the color coding on the graphics. While the California side, due to Pacific subduction, is actually slightly sinking. Right in the middle, in between the West Coast subduction and the Alaskan uplift, is Prince Rupert, British Columbia. They too have a co-located GPS that's been there for over 10 years. We can verify and validate sea level rise because of that. So here we have Prince Rupert, British Columbia. They have a subsidence of 0.07 millimeters a year. They're recording 1.17 millimeters a year. What's the next rise? 1.1. And again, superimposed is the CO2, but the trend is decidedly linear. There's a drop, by the way, in 2011 to 10. I'm going to talk about that in a minute. Take a look. This is all over the world. This is not every tide gauge, but my goodness, if I expand this, it doesn't make a difference. They are all linear, straight line change. Some are going down, some are going up, depending on local tectonics. Now, this is Slipshaven, Denmark. Slipshaven, Denmark is also in Europe, and it also is between the great Norwegian uplift and the Low Countries sinking. But in that area, it's 1.03 millimeter rise a year, straight line, linear. Next slide, please. CO2 does not affect it. So I ask, is CO2 a major driver of the coastal sea level rise? It may drive the IPCC's models, but it plays no role in worldwide coastal sea level rise as measured by tide gauges. So the IPCC is saying, hey, this is what's going to be happening with sea level rise. And you'll notice, by the way, in the current US National Climate Assessment, this rise starts in 1992. Remember that date because we're going to be talking about it later. And these are all off the wall, off the charts. Sea level by the tide gauges is still linear, hasn't changed, and yet they're talking about 8 feet of rise by the end of the century. This is a chart from the Netherlands. It's in Dutch, but it also starts in 1992, and they're also projecting a rapid sea level rise along the Dutch coast. Guess what? It's not going to happen. This is a mantra at NASA. You measure the measurements, you measure, you calibrate them, you validate them, and I left one term here, you verify them. And we're going to be talking about verification later on. My NASA colleagues are all familiar with "In God We Trust, all others bring data." Well, I'm bringing you data. This is a history of sea level rise. Now, by the way, the sea levels measured on these charts are verified and validated through geological evidence, not models. And you can see the whole list of places in the world where we've measured them. We've had 140 meters of sea level rise since 2,000 years ago. You notice most of the rise took place during a 7,000 year period. That's an incredible rise in 7,000 years. And then it levels off. The chart on the right shows you where it levels off to. During that 7,000 year period, there was a meltwater pulse. It basically dumped out the giant Lake Bonneville and dumped it into the Snake River once an ice dam broke. Lake Agassiz followed too. And by the way, I want you to look at these rocks. These are photographs I took along the Snake. And by the way, on the left rock there, you see some petroglyphs. We can date these rocks very accurately. When Lake Bonneville dumped out thousands, no, tens of thousands of these round rocks rumbled down the Snake River. That's some of the petroglyphs on the rocks. There you see hundreds of rocks here. Along the Snake, there are tens of thousands of these. When that giant lake emptied out, rolled these rocks down the river, and a Snake went all the way into the Columbia and out to the Pacific. This is a huge, giant meltwater event. Here we go, back to all that 7,000. You can see where that meltwater pulse is. Maybe I can show it in my cursor right here. How you like that? Okay. Jim Hansen is telling you that in 80 years, we're going up 16 feet. And this trend line, by the way, represents a satellite trend line. I'm going to talk about that later on. We have to invent new laws of physics to add those 5 meters in the next 80 years, when over 7,000 years, we had very little rise. This is a tide gauge. This one happens to be out in Fort Point, New Hampshire. It's anchored to the bedrock. There's a monitoring station. Tides vary a lot in Portsmouth. Tide gauge is very accurate. But there's a bias in tide gauges. Why? People put tide gauges where they believe that the sea is rising, which means the land is falling. So if you average all the tide gauges, it's going to look like sea level is really going up. But it's not. You have to look at the individual ones, and especially the ones that are in tectonically inert areas. These are Europe tide gauges. They have all have 80 years or more records. Lots of them are in the area of transition here. Holland sinking, Norway rising, Denmark right in the middle. This is what isostasy is all about. You put 2 or 3 miles of ice on top of land, it pushes down the land into the asthenosphere. On the edges, you have what are called a forebulge. That's the current day Netherlands. These are tectonics in the Baltics. The highest rise, 800 meters in central Norway. Down here in Holland, the Netherlands, sea level is rising 170, which means the land is sinking. Right in here is the tectonically inert zone. This is a close-up of that tectonically inert. Here is a zero line, and what we want to do is look at the sea level on that zero line. And this is Slipshaven, Denmark. It's, again, totally linear. CO2 going up, 1.02 millimeters a year, over 100 years of record, no sign of acceleration. Now, there are some places in the world where NOAA is declaring sea level is rising like crazy. Well, Seward, Alaska is one of them. And the red line shows the sea level rise line claimed by NOAA. And it's quite huge. But this is not true. What happened in Seward is in '64, they had an earthquake. Seward dropped. Sea level before was slightly falling. Sea level after the earthquake, right here, is also falling. The trend in sea level is still falling, mainly because it's in Alaska, where Alaska's land is rising. And it's still linear. There is no upward trend in Seward, Alaska. Oh, by the way, I contributed to a paper that was published in 2019 that I co-authored with Nils Axel-Murner and Albert Parker, where I go into real detail about the Seward, Alaska earthquake and the effect on sea level rise. I'm going to send a link to it to Jim Peacock, and if you guys want to download the paper, it's published in an oceanographic journal. So let's go to the next one. This is computational errors. The Americans put up the Topex, Poseidon, Jason satellites with France. And we're doing it for medium orbit. That's 800 miles up. It's higher than ENVISAT. So it's not that accurate. This is what you're still looking at linear sea level rise, but the rate is way higher as measured by these satellites. The latest, still linear, big drop in 2010, which validates some of the other slides. This is Prince Rupert, BC. You see the difference between the satellite readings from Topex, Poseidon and the real readings by tide gauge. This is the resolution issues. Topex, Poseidon does not have a sufficient resolution to measure at the 1 millimeter level. It has 2 orders of magnitude, almost 3. They can't do it. Why do they use 2 radars? It turns out that the C-band, which has an even lower resolution, is very good for penetrating clouds. Roy Spencer supposedly posited that the clouds are a problem. He's correct. This is the problem. Clouds are filled with little ball lenses. A ball lens reflects 5% of the incoming light, transmits 95%. So you see, as that attenuation goes down to the cloud, the bottom gets really dark. The problem with the satellites is they have 2 radars, but only 1 antenna, and they have to pick which one. So when they're flying over clouds, like over here in the Central Pacific, they have to switch to the larger, low-resolution waveband in order to get a good, accurate reading. I'm going to skip the GIA because there's some detail here, but I'll have looking questions if there are any. Now, here's the big slide. What happened in 1992 that forever changed the direction of sea level rise as reported by that satellite? Did we get hit by an asteroid? Did we change our orbit? None of that happened, and yet the sea level rate changed. And by the way, that little red arrow there, that's where the real sea level ended up. This is an IBM 340 mainframe. It's the kind of computer that I worked on at NASA. What you do, these mainframe computers could do one thing really well. They could add. So when you made a subroutine in machine language, you basically forced it to add, and add. So you take the sum of the C band and the KU band, you add it to itself 5 times. Again, adding. You shift the decimal 1 place left, and you have effectively multiplied the sum by 5 and divided it by 10, which is really dividing it by 2. And it's precise, not subject to error. However, they use a higher level language at the University of Colorado to analyze these radars. They added them together, but they forgot to divide by 2. Or they put the number 2 in a register, overrode it by a 1, and then declared that as being the average. You have 2.9 millimeters a year reported by the satellites. You've doubled the radar, not averaged it. You knock out GIA by 3 millimeters, and you get exactly the same worldwide sea level rating, 1.15 millimeters a year. And that takes you to the red arrow that you see on the right. This is the real sea level. not what you see reported here, because this is a computational error and the University of Colorado should be penalized for it. This is the slide you need to remember. Science is not complete when you thankfully achieve the result you were expecting, and they were expecting sea level to go up. You have to measure, calibrate, verify, and most important, validate it to other measures that we know are hard, solid data. They did not do that. Next slide, please.
We're at the end.
Okay, one more slide.
No.
If your institution is not releasing your computer code, next slide.
No. Tom, over.
Yeah, they are.
One question.
We're done.
The attribution of sea level rise, what percentage of that is thermal expansion since the end of the Little Ice Age, and what percentage is, say, melting of the ice caps or some other source?
Well, the fact is, if you look at the last graphic of sea level rise, that is the exact sum total of all the thermal expansion, all the ice melt, and any other change we have in sea level rise. And it is linear, it is unchanging.
Yes, I'm not questioning that. I'm just asking can you explain the sea level rise to be predominantly due to thermal expansion, due to warming of the oceans since the Little Ice Age ended?
No, it's actually more land ice melt slowly adding to the oceans, but the ice melt is melting at a very linear rate. Greenland is increasing its interior ice depth, and it's decreasing the edges where they're spilling into the sea, but it is linear. The same is true as Antarctica, but Antarctica actually has a net increase in balance, as demonstrated in the Zwally paper.
Okay. So the sea level rise doesn't support the hypothesis of net melting of the ice caps at an accelerating rate right now.
Now, keep in mind, the floating ice in the north, in the Arctic, is not going to raise sea level at all because it's already displacing all the water that it does. And it melts and refreezes annually with no real effect on sea level.
That's basic physics. Tom, thank you very much for taking time. Enjoy it.